All right, how's it going, everyone? Excuse me. So now that you've had some time to work on this activity in your groups, let's debrief these like sample student answers, and then add some more formal language um, to this topic of experiments and observational studies. All right. So the context that we're dealing with here is a high school, East Kentwood High School. They offered an after-school SAT prep class that students could volunteer to take. 44 students took the course, and then they took the SAT when they were done with the course. And the average SAT score for this group of students was 1220. Now, the average SAT score for all students who didn't take the prep class was 1050. Okay, so already we're kind of seeing some promising results. All right, so question number one, is this situation an observational study or an experiment? So your typical student would say that this is an observational study because they recognize that the students were not forced to take the class, right? They voluntarily took the class. And when we think about experiments, right, a lot of times we think about like science experiments, right, where a scientist is manipulating or controlling something. Okay? Well, statistical experiments aren't that much different either, right? There's a researcher who is gonna like manipulate and control certain individuals in the study. Okay, but that's not happening here, right? Our 44 students aren't being controlled in any way. They're kind of left to do whatever they want to do. Okay, so we're merely just observing what happens naturally by these students. All right. So here's some formal language that I want you to add. Use red for these notes here. All right. So an observational study is one in which there's no treatment being imposed on the individuals. An experiment, on the other hand, is one where a researcher is imposing treatments on some subjects, but maybe not others. Now, imposed is just kind of a nice way of saying like we're forcing that treatment on them, we're assigning it to them. Okay, let's move on to question two. All right, so we want to identify the explanatory and response variables in this study. And so one might describe the explanatory variable as the SAT prep class itself. And then we might want to describe the response variable as that final SAT score. And so we used these terms back in Unit 2 when we were studying scatter plots. Right, the explanatory variable would go on the x-axis and the response variable would go on the y-axis. Okay. And what did we say before? We said the explanatory variable is what we use to predict some outcome. So let's write here, explanatory is what's being used to help us predict. Okay. And then the response is simply the outcome, right? The end result, right? The final measurement. Okay. Now, unfortunately, these identifications would not be strong enough to get full credit on an FRQ because the phrase SAT prep class is a little bit too vague, right? What does that refer to? Is it the cost of the prep class? Is it the time of day that it was offered? Is it the length of time? Okay, so there's a lot of characteristics to that SAT prep class, and simply writing that alone isn't clear enough. Okay. So we need to be a little bit more intentional, right, when we describe the explanatory variable. Okay. So the way that I'd like you to write it is whether or not a student took the prep class. All right, so moving on to part three. Can we conclude that taking this prep course causes a student's SAT score to increase? Okay. Why or why not? All right. So this student response says no, right? We cannot say that caused the score to increase because students who take the course might have just been highly motivated, They might have just been harder workers to begin with, okay? Or just might have studied more to begin with. So it's really hard, nearly impossible to show that one thing causes another simply by observing it. Okay? We need to design a controlled experiment to actually show cause and effect. So let's write this in the right margin here. So we need an experiment, not just an observational study, in order to show causation. All right. So we kind of already alluded to, maybe these students were more motivated. Maybe they just are more studious. Maybe they study more. But in question 4, we're going to try to think of, well, what other factors, what other forces might have been in play that led to those higher SAT scores? So identify as many other possible variables that you can that may explain why the SAT scores are higher for those who took the prep course versus those who did not. So we've already talked about motivation level. Maybe the students who signed up for the course are like more college bound to begin with. Okay. Maybe they just have more time. Okay. Maybe they don't have a job. Maybe they're not playing sports. Maybe they don't have siblings to take care of. Maybe they just have a lot of time to study. Okay. We can also look at the number of AP classes a student is taking. Right. We know that AP students like yourselves are very highly motivated and try to do well, want to do well on standardized tests. Okay. So this list that we've created, and it's only has 4 items. We could add way more items here, but these other factors are called confounding variables. So on our margin, let's go ahead and write that term, confounding variables, right? These are other factors, other forces that are playing on that outcome, in this case, SAT score. All right. So sometimes it's helpful to draw a diagram showing the relationship between all these variables, right? And there's 3 different types. There's these confounding variables, type number 1, okay? There's the explanatory variable and the response variable. So that's 3 different types of variables. And let's diagram how they all interact with each other. All right, so the 2 variables that we're really interested in is that explanatory and that response. Okay. So the explanatory was whether or not somebody took the prep course, and then the response was the SAT score. And we kind of saw that there was an association between these 2 things, right? Students who took the course had a noticeably higher score. What was it, 1220 versus 1050? Sorry, so it's almost a 200-point difference, okay, in their SAT score. So an association does exist. And we would like to say, right, that one causes the other, right? That taking the prep course caused the scores to get higher. Okay. But we can't quite make that conclusion, right? We can't say that one causes the other because, as we alluded to, there's all these other forces in play, all these other factors that impact SAT score. Okay, and we're just going to write one of them down. Let's write motivation level. So it's quite clear, it's kind of common sense that a more motivated student is probably going to perform better than a less motivated student. And we also could imagine that if you are more motivated, that might make you more inclined to sign up for the course in the first place, right? So there's going to be an association between motivation level and taking the course. there's probably going to be some cause and effect between motivation level and the SAT score, right? And all we know at the moment is that there's an association between taking the prep course and getting a higher SAT score, but we can't quite pin it down on the course itself, right? We can't say the course is the reason why or the cause why the SAT score was higher. All right, so we mentioned in question 3 that if we want to show causation and not just association, we've got to design some experiment. Okay. So here's an example of an experiment that a student described. So let's just kind of randomly choose 100 students, 100 juniors at the school, okay, and then we'll split them into 2 groups. Okay, one group is going to be assigned to take the prep course, and the other group, the other half, will not. Okay, and that'll be the decision of the researcher. And then a month later, or however later it is, we'll have the students take the SAT and then compare the scores between the 2 groups. Okay. So this is a valid way of describing an experiment. Okay, probably would get full credit on an FRQ. Okay. But another way that we can describe this is in a flow chart, right, or a diagram. Okay, so right now it's written in paragraph form, but let's kind of convert it into a flow chart. All right, so I'll teach you how to do that now. All right, so we've got 100 juniors. Okay. And then the key thing here is, we're not going to let them pick. We're not going to let them volunteer. We have to impose it. Okay. So how do we impose it in a fair way? Well, let's just do it randomly. Okay. So we're going to randomly assign, okay, these 100 juniors into 2 groups. Okay. And we'll try to keep the groups more or less balanced. So 100 divided by 2 is 50. Okay. So group 1 is going to include 50 students, and group 2 is going to include another 50 students. And now after we form these groups, then we can impose the treatment on one of the groups. Okay. So in this case, we'll just impose it on group number 1. Okay. So group 1 is going to be assigned to take the SAT prep class, and group 2 does not get the class. And then after a month of either getting that treatment or not getting a treatment at all, we'll compare the SAT scores between the 2 groups. Okay. All right, so this flow chart captures all the ideas in that paragraph, right? We have 100 juniors. We randomly split them into 2 groups or 2 halves. One half gets assigned or imposed the prep course and the other one does not. And then there's some comparison that happens in the end. All right, so let's talk about the different components in this flow chart. All right, so the 100 juniors, all right, we're going to refer to them as the experimental units. I'm curious, I'll probably ask you guys on Tuesday if that's the same terminology that's used like in AP Psychology. I know you guys do a unit on experimental design. Okay. If the experimental units are humans, as is the case here, we can just call them subjects. Okay. But the more general term is an experimental unit. All right. The random assignment has a very important purpose. Okay. The purpose of the random assignment is to, how should I say, equally equally distribute all those confounding variables. Okay. Right. So it would be a terrible design if all the motivated students ended up in one group, right, and all the less motivated students ended up in the other group. Okay. Because then right? If all the motivated students ended up in group one and they got the SAT prep class and then they got the higher scores, now there's two potential reasons for why that happened. It could be because of the course, or it could be because that group was mostly motivated students. So by assigning students randomly or splitting them up randomly, that should evenly balance out the motivated students into both groups. And it should also evenly balance out all the other factors, all the other confounding factors, right? Like, some students are going to be college bound, other ones aren't. Okay, when we randomly assign the students into these two groups, those college bound students should get split up evenly between the two groups. Okay, students who have a lot of time after school, right? If we do the assignment randomly, those students with a lot of time are going to get split up evenly between the two groups. Okay, our students who take a lot of AP classes, okay, because we're assigning them randomly, they should get split up pretty evenly into these two groups. Okay, so by randomly assigning students, right, we are basically creating roughly equivalent groups. And this even accounts for things that we haven't even thought of, right? We only listed like 4 confounding variables, okay? But random assignment is going to equally split up the levels of other confounding variables that we haven't even thought of. All right, so we have now these two roughly equivalent groups, okay? So there's really no systematic difference between them until we assign the treatment. And so now the treatment is the only systematic difference between the groups. Let's write it over here. Okay. So there should be nothing else different about these groups except for the fact that one got the treatment and one didn't. So then when we compare the scores at the end, right, we know there's only one variable that was different between the two groups, which was the SAT prep class. Okay, so that could be the only logical reason for why the SAT scores differed, right? It's not going to be because of motivation level, because we know that motivation level would have got split up evenly from the random assignment. Okay, any differences in the SAT scores aren't going to be based on the student's family income or affluence, because random assignment would have split that up equally as well. Okay, differences in the SAT scores cannot be due to what was another one we had? How much time a student has after school, right? Because that factor would have got evenly split up by the random assignment. So the only systematic difference between the groups is whether or not they took the prep class. And so any differences in the SAT score can be pinned down to the prep class now. All right, so let's go ahead and move on to the important ideas and kind of summarize in a formal way what we learned in this activity. Right, so number one, let's just go ahead and define the different types of variables in a study. Okay? So we have the explanatory variable. Okay? And this we want to think of as a variable that's going to help explain or help us predict the response. And then, of course, we have the response variable itself. And we just want to think of this as the outcome that's being measured in the study. But then we have to acknowledge the fact that there are confounding variables, right? That there are sometimes these other forces, these alternative factors that might be playing roles in between the explanatory and the response. All right, so let's describe these as influences, variables that influence both the explanatory and the response variable. Forces that influence both the explanatory and response variables. All right. So we had drawn a diagram showing how these three different types of variables relate to one another. All right, so let's just make a generic copy of that diagram here. All right, so E is for the explanatory, R is for the response. Okay, a lot of times, even in an observational study, right, you'll see an association between an explanatory and a response variable. Okay? We represent associations with these dashed lines. Now, what most researchers want to show is they want to show that the explanatory variable causes changes in the response. Okay? And we can't always show that. Okay, so I'm going to draw a solid arrow to represent a cause and effect relationship, but I'll put a question mark above it because we can't always say, we can't always prove that that there's causation. And the reason why we can't prove that there's causation is because of those other factors, those other forces that influence the response. So those are our confounding variables. Right? So those are also causing changes in the response simultaneously, right, at the same time as our explanatory variable is. Okay? And what makes matters even worse is that confounding variable is probably going to be associated with the explanatory variable too, right? So it's kind of like this, for lack of better words, like a love triangle between these three variables, and it's really hard to tell where the true relationships lie, where the true cause and effect relationship lies. So the rest of our important ideas are going to be more or less definitions. Okay. So we were debating at the very beginning, what type of study was this? Was it observational or was it experimental? Okay. And so the big difference between the two is that in an experiment, we impose treatments, and in an observational study, we do not. Let's kind of separate these ideas here. So in an observational study, we simply observe, we don't disturb. Cool rhyme, I can't take credit for that though. All right, so there's no treatment. Okay, people just kind of do their own thing, right? Kind of, when I think of an observational study, the image that always comes to my mind is like Jane Goodall, like in the jungle, just like watching chimpanzees, right? She's not really imposing any treatments on them. She's just watching and observing and recording in her notebook, right? That's my go-to image of an observational study. All right, an experiment, okay, is a study in which the researchers impose treatments. Right? And the reason why we do this is because we want to show that the treatment actually is causing changes in the response. Okay. So for better or worse, right, the only type of study that can show whether one variable causes changes in the other is an experiment. Okay. An observational study cannot show causation. Okay. It can show association, right, which is not as strong of a relationship as causation. All right, we're going to squeeze a couple more definitions in here and then kind of wrap this thing up. So we introduced some new terms. The experimental units are the people or animals or inanimate objects, right, that we impose the treatments on. So we'll say what or who the treatments are imposed on. Um, so experimental units can be people, could be animals, or it could be inanimate objects, right? Think about a chef who's maybe experimenting with different temperatures and different times for baking a cake. Okay, so the cakes or the batters, I don't know, right, would be the experimental units, and then we test out different temperatures and different times to determine what produces the best cake. Okay, treatments. Let's keep going here. um, is what is being done or maybe not done on those experimental units. Okay, so in the context of our activity, the treatment was the prep course, right? You either were assigned to do it or you were not assigned to do it. Okay, so that should just about do it. Hopefully you guys have a little bit of time left in class to get some work done. You can work on the check your understanding questions. Um, Actually, yeah, that would be my preference, is that you work on those. If you've already kind of looked at that, then you can grab a laptop, get on my AP, and maybe take a look at some of the topic questions or watch some of the College Board videos, which are much better, much more better put together than this video you guys are watching here by me. Okay, I'm rambling. It's Friday. I hope you guys have a good weekend, and I'll see you on Tuesday.